electrochemical cells. Okay, right. Now I will explain about electrochemical cell. For this electrochemical cell, we take galvanic cell. Okay, electrochemical cell. To explain about electrochemical cell, here I take galvanic cell. Right. You see, in electrochemical cell, here the energy conversion is chemical energy. Chemical energy, it converted into electrical energy. So in electrochemical cells, the energy conversion is chemical energy, it converted into electrical energy. And when you take an electrochemical cell, in that a spontaneous redox reaction takes place. Okay, so in electrochemical cell, a spontaneous redox reaction takes place. Okay, you see here redox reaction means in a reaction oxidation and reduction both are takes place, it is called redox reaction. So if you take an electrochemical cell, in that spontaneous redox reaction takes place. And when you have to see here, we use two electrodes, anode and cathode. Okay, right. Now listen. So in electrochemical cell, anode is negative electrode and cathode can be act as positive electrode. So in electrochemical cells, anode is negative electrode, cathode is positive electrode. Okay, right. Now you see, at anode the reaction takes place is oxidation of reaction, and at cathode the reaction takes place is reduction of reaction. Okay, so you see at anode releasing of electrons takes place. So in a reaction, if releasing of electrons takes place, it is called oxidation of reaction, and at cathode the electrons are gained. So in a reaction, if electrons are gained, it is called reduction of reaction. So at cathode reduction of reaction, at anode oxidation of reactions takes place. Okay, so you remember that in electrochemical cell, anode is negative electrode, cathode is positive electrode. If you take electrolytic cells, in that anode is positive and cathode is negative electrode. Okay, it is in electrolytic cell. Now in electrochemical, anode negative, cathode positive. Okay, and you see here the energy conversion is chemical energy converted into electrical energy. Okay, right. And in these cells at anode, okay, so you see at anode electrode, loss of weight takes place. Okay, so here loss of weight takes place at anode, and at cathode gain of weight takes place. Okay, because at anode electrons are released, due to releasing of that electrons at anode, here it lost some weight. Okay, so anode electrode lost some weight and that electrons are gained by cathode. Okay, that's why at cathode here weight is gained. Okay, so to explain about this, here you take galvanic cell. So in galvanic cell, you have to construct it like this. In galvanic cell, you take a zinc sulfate solution and copper sulfate solution. Okay, right. So here in galvanic cell, you see we have to take two op cells. It is one op cell and it is another op cell. Okay, right. So you see in this we take one electrode. Now it connected like this. Here you take voltmeter or ammeter, and it is connected to a battery. Now it connected to another electrode. So these are two electrodes. Okay, right. Now in this we take electrolytic solution. Okay, the electrolytic solution in this I take zinc sulfate. Okay, so it is zinc electrode. Here zinc electrode I take in zinc sulfate solution, and in another op cell the solution is copper sulfate solution. Okay, so it is copper electrode. Okay, it is zinc electrode and it is copper electrode, and here zinc electrode can be act as negative electrode, copper electrode can be act as positive electrode. Okay, so it is a negative electrode means it is anode, it is positive electrode means it is cathode. So already we see that at anode releasing of electrons are takes place, and at cathode gaining of electrons are takes place. Okay, so here electrons are migrated from anode to cathode. Okay, so here electrons are released, that electrons are gained at cathode. Okay, right. Now listen. So here electrons migration only takes place. It is called outer circuit. The migration of electrons takes place in outer circuit. Okay, right. Now to connect these two cells, you use another one, that it is called salt bridge. Okay, it is called salt bridge. To connect these two cells, you use a salt bridge. Okay, right. And this, it is a cotton black. Here you take a cotton black. Right. Now, so it is called salt bridge. This salt bridge can be act as an inner circuit. Okay, so the salt bridge can be act as an inner circuit. Right. So when here reactions are takes place at electrodes, you see at anode, this zinc electrode participate in the reaction. So this, by releasing electrons, it can be formed as Zn plus 2. Okay, so now zinc electrode, it enters into solution, Zn plus 2, Zn plus 2, like this. So here releasing of electrons takes place, oxidation of reaction. Okay, due to this, here zinc electrode, it converted into Zn plus 2. Here the weight of electrode, it some decreases. Okay, so here zinc electrode, it converted into Zn plus 2. That Zn plus 2 ions are enter into electrolyte solution, and released electrons are transferred towards cathode. That's why here the size of anode somewhere it is decreases. Okay, and now you see at cathode, the electrons, released electrons, that are gained by copper ion. Okay, so here the released electrons are gained by copper ion, and it is reduction of reaction. Okay, right. You see here you take CuSO4 solution. In CuSO4, here copper can be present as Cu plus 2. Okay, this Cu plus 2, it gains these electrons and it can be converted into copper. Okay, copper electrode. That's why here the weight of electrode somewhere it is increases. Okay, so here at copper electrode weight increases, at zinc electrode weight decreases. Okay, so here oxidation of reaction, reduction of reaction takes place. So it is a redox reaction. Okay, now we have to write the total equation. We can write like this: zinc solid plus Cu plus 2 in aqueous form. It can be formed as Zn plus 2 aqueous form plus copper solid. Okay, so this reaction takes place in galvanic cell. Okay, so when you have to write in cell representation form, generally we write like this: metal ion double slash metal ion metal. We take like this. Okay, it is one reaction at one electrode, and it is reaction at other electrode. Okay, so generally you see this reaction we take which is takes at anode, and here we write the reaction which is takes place at cathode. In between anode and cathode, here we write a double slash. This indicates nothing but salt bridge. Okay, so this we have to write for galvanic cell. You see, in galvanic cell at anode, first you have to take zinc metal. Now it changes to Zn plus 2 ion. Okay, and here we take salt bridge, and in cathode Cu plus 2 is present. It can be formed as Cu. Okay, so while writing cell representation for galvanic cell, we can write like this: Zn plus 2 double slash Cu plus 2 Cu, and this double slash indicates it is nothing but salt bridge. Okay, this like this reaction takes place in galvanic cell. Okay, right. Now we have to see in this galvanic cell why we can use here salt bridge. What is the importance of salt bridge? Now we have to see. Right. So I will explain about importance of salt bridge. Okay, right. Now listen. So in the importance of salt bridge, before we have to studying about that, first we have to see in salt bridge an inert electrolyte is present. In salt bridge an inert electrolyte is present. Here we have to take a KCl, NH4, NO3, KNO3 like this. Okay, these can be taken as electrolytes in salt bridge. Okay, right now we have to see, when you have to take like this, these are actually active electrodes. Okay, these are inerted by boiling with. Okay, we take this electrode, these are boiled with a substance like agar. Okay, so these electrolytes actually active electrodes. When these are boiled with agar like substance, this can be formed like jelly like substance. Okay, so after cooling we get jelly like substance. When agar is presented with this can be act as inert electrolyte. Okay, so here we take inert electrolytes. Okay, right now see, when you have to take inert electrolytes, here we have to remember that the ionic mobility of cation and anion, we have to take equal mobility. Okay, so we take inert electrolyte as which having equal mobility of cation and anion. Okay, that we have to select as inert electrolyte. KCl, here K plus Cl minus, both are having equal ionic mobility. Here also same, here also same. Okay, so it is a electrolyte present in salt bridge. Here one inert electrolyte is present in salt bridge. We take an active electrolyte. When it is boiled with agar like substance, we get jelly like substance. And here we take electrolyte which is having equal ionic mobility. Okay, it is about inert electrolyte. Now you see the importance of salt bridge. Here the importance of salt bridge, you see, when the reaction takes place, here zinc Zn plus 2, here concentration of Zn plus 2 increases. Here the concentration is decreases, because here number of Zn plus 2 ions are increases. Here number of Cu plus 2 ions are decreases, due to here some potential difference is present. Okay, so here more number of cations are present, here less number of cations are present. So to balance these electrical neutrality, we use salt bridge. Okay, so the importance of salt bridge is to maintain electrical neutrality. Okay, to maintain electrical neutrality, here salt bridge is used. Okay, what it's done? Okay, right now we see in the solution more number of H plus ions are present. Okay, and here less number of cations are present. So here less number of cations are present. That's why here it gives cations, and here it donates anions. Due to that, here charge neutrality takes place. Okay, so to maintain charge neutrality, the salt bridge is used. Okay, it is one. And you see, to complete circuit, here salt bridge is used. Okay, so you see, it can be used as outer circuit. In that, which are migrated, electrons are migrated. So in salt bridge, it can be act as inner circuit. In this inner circuit, which are migrated, ions are migrated. Okay, by migrating ions from salt bridge, electrical neutrality takes place and it completes the circuit. And another importance of salt bridge is to stop liquid junction potential. Okay, so it is useful to stop liquid junction potential. So when liquid junction potential is present, okay, if you see these two electrolytes are directly combined, then liquid junction potential is present. To stop this liquid junction potential also, your salt bridge is used, because from this only this cation and anion are migrated. These two solutions are not mixed. If these two solutions are mixed, we have to get some liquid junction potential. Due to that, some potential difference is present. To stop this liquid junction potential, your salt bridge is used. Okay, so when we have to use salt bridge, these two electrolytes are not mixed. So these are the main importance of salt bridge. So it is mainly useful for to maintain electrical neutrality. In these two solutions, when electrons are migrated, then here neutrality is not present. So to maintain neutrality, your salt bridge gives required number of ions for these two. That's why your electrical neutrality is maintained. And to complete circuit, your electron migration takes place in outer circuit, ions migration takes place in inner circuit. Due to this, here the circuit is completed, and to stop liquid junction potential, your salt bridge is used. Okay, so it is about galvanic cell and salt bridge.